Here's one way to derive the gas density equation, given that density is equal to mass over volume, and you have the ideal gas law, which says that PV equals nRT. So there's multiple ways to do it as long as you don't break the rules of math. But first, we notice that there is a V in the ideal gas law, and there is a V, both of which mean volume, in the density equation. Now you can use D for density or you can use rho for density. They are just two different ways to represent density. I'm actually going to stick to D in this video, but you may have seen me use rho. Sometimes it doesn't matter. Just get used to seeing both. But rho kind of looks like a P, so I'm just going to avoid it in this case. So if D equals M over V, we can rearrange this equation to get V equals M over D. Volume is equal to mass divided by density. Then we can take this and we can plug it in for where V is in the ideal gas law. And that'll give us this. P times, and then inside we're going to put mass over density is equal to nRT. Now, the rules of math, associative properties, and all that stuff basically say we could rewrite this as P times M divided by D equals nRT. And then if we solve for D, what we're going to get is we just divide both sides by nRT. So if we divide the left and the right by nRT, nRT comes down, D goes up, and we get this. I'm actually just going to move these over here, make that a little larger. And all we get is that density is equal to pressure times mass divided by moles times R times T for temperature. So how do we actually get the standard looking density equation? We can recognize something neat that happens, and that's this. M and N. M stands for mass, which we measure in grams, and N stands for moles, which we measure in moles. So I'm going to actually check the units. We can shrink these things down because we don't really need them anymore. Checking the units, we are going to see what's going on here. So I'm going to put in all the units. The goal unit for the density of a gas in chemistry is generally, I'm going to do them in orange, grams per liter. Those are the units we're going for density. And that's going to be equal to, the units for pressure are ATM. And there are multiple units for all sorts of these. We're going with the standard ones that you'll likely see. But just remember that units are units. They can be whatever. So ATM. And then M is mass measured in grams. On the bottom, we have moles, MOL. The R constant has some weird units that are all derived, but it's atmosphere liters, or liter atmospheres, per mole Kelvin. And then we also have temperature in the denominator, which is Kelvin. So going back here, we have pressure, we have mass, we have moles, we have R, we have T. We have all their units here. Let's see if we can cancel out some of their units. ATM is going to go here and here. Moles is going to go here and here. Kelvin is going to go here and here. And look at the units left over. You have grams and liters. Also worth noting, where does molar mass come in? That's going to come in right here. So let's pick some other random color like this golden color. And we see that we have grams and moles. Notice how grams is on the top and moles is on the bottom. That's fine because that is actually just molar mass anyways. So grams and moles are really just grams per mole, which is molar mass. So there's multiple ways to represent molar mass. We can kind of pull those out. And what we get, rewriting with the unit check, we have grams per liter is equal to, we have our ATM still, but then we could actually put grams per mole all in the top. And then in the bottom, we still have our R constant, atmosphere liters per mole Kelvin. and then we have our Kelvin. So replacing the units with their actual variables, so now we're kind of working backwards with it. We have density is equal to pressure times molar mass. Sometimes you'll see it as like a sideways looking italic M. I sometimes put mm for molar mass. And that's divided by R times T. So density, pressure, molar mass, R constant, and temperature. And this is generally the density equation for a gas that you will see.